Welcome students. We are expected to find the value of x given that x raised to the power of 4 is equal to x negative 1 raised to the power of 4. I'm going to probably give you 5 methods to solve this question, and you can pick up the method that you want. Now, on the first examination, you might think that this is a quartic equation, but it is not a quartic equation. It is a cubic equation, because when you were to, if you were to expand left side and right side, x raised to the power of 4 will get cancelled. So this is a cubic equation. So we will get 3 roots, and of the 3 roots, we will only have one real root. Now, how did I say that? You will understand during the course of this entire solution. And let me just give you the first solution. So this is solution 1. What I wish to do is I would like to rewrite this as x raised to the power of 4 negative x negative 1 raised to the power of 4 is equal to 0. I would like to write this as x raised to the power of 2 raised to the power of 2 followed by a negative sign, and this is x negative 1 raised to the power of 2 raised to the power of 2. Now let me take x squared to be as a and x negative 1 raised to the power of 2 to be as some b. So if I were to do that, I would get here a squared, of course this is equal to 0, negative b squared, right? X negative 1 raised to the power of 2 is b, so this is going to be b squared is equal to 0. Now we can rewrite this as a negative b multiplied with a positive b is equal to 0. Now I would like to revert them back to x and x negative 1. So this is nothing but x squared followed by x negative 1 raised to the power of 2, and then x squared positive x negative 1 raised to the power of 2 is equal to 0. Now I've got two components is equal to 0. Now from algebra I know that if a times b is equal to 0, then either a is equal to 0 or b is equal to 0. Now what I would do is I can choose one of the following. I can just expand this first and then I would apply this, or apply this and then expand it. Okay, anyway, what I will do is I will just expand these terms first. So this is going to be x squared negative x negative 1 raised to the power of 2 will give me x squared negative 2 times x positive 1 times x squared positive x squared negative 2 times x positive 1. This is equal to 0. So clearly x squared negative x squared gets cancelled. This is going to give me positive 2x and negative 1 times x squared added with x squared will give me 2 times x squared followed by negative 2x positive 1 is equal to 0. So if I were to take 2x negative 1 is equal to 0, from here I get 2x is equal to 1 and then x is equal to 1 over 2. So this is a solution. Just go to the other end. The other end we add 2x squared negative 2x positive 1 is equal to 0. So I would be using the quadratic formula. In this case x is equal to negative b, so it's going to be negative of negative 2 plus or minus root of negative 2 squared, negative 4 times a times c divided by 2 times a. This is going to give me 2 plus or minus root of 2 squared with a negative sign, that's going to be positive. Minus 4 times 2 is 8 divided by 2 times 2 is 4. This is going to be 2 plus or minus root of negative 4 divided by 4, which is 2 plus or minus root of 4 I squared divided by 4, which can be rewritten as 2 plus or minus 2 times I divided by 4. I can take 2 common and I can rewrite this as plus or minus I divided by 4, which is nothing but 1 plus or minus I divided by 2. In fact, I can write the roots as 1 plus I divided by 2 and 1 minus I divided by 2. So we got a complex root. So therefore the roots are, I can just sum it up. So the roots are, I get one real root, that's 1 over 2, and two complex roots, one negative I divided by 2 and one positive I divided by 2. So this is the first method, and I will go on to show you the next method. Now this is method 2. Now let us start with the question. We are given x raised to the power of 4 is equal to x negative 1 raised to the power of 4. I already mentioned to you that this is not a quartic equation, it is a cubic equation, and you will see it. Why did I state it in that fashion as we move on from method to method? So this is the second method, which will provide you some greater further enlightenment. Now I'm going to rewrite this as x negative 1 raised to the power of 4 times 1. It's possible, right? It is acceptable, and on the left hand side it is equal to x raised to the power of 4. Now taking fourth root, this would give me x, and this would give me x negative 1, and this would give me 1 raised to the power of fourth root, 1 over 4. Now we know the fourth root of unity. Fourth root of unity, in this case unity is 1, and that is given to be as 1, negative 1, I and negative I. So this is the value for fourth root of unity. So if I were to take 1, I would have x is equal to x negative 1 multiplied with 1. This is the first case. Second case, x is equal to x negative 1 times negative 1. Case 2. Case 3, x is equal to x negative 1 times I, and then finally x is equal to x negative 1 negative I. Now if you were to take x is equal to x negative 1 times 1, you would get x is equal to x negative 1, which means x negative x is equal to negative 1, 0 is equal to negative 1. This is ruled out. Okay, so that means we don't have this to be featured among the roots, and that's the reason it's a cubic equation. And from here it's going to be negative x positive 1 is equal to x, and if I were to move negative x to the other side, you get 2x is equal to 1, therefore x is equal to 1 over 2. So this is a root. Coming back to this point, you get x is equal to x times I, negative I, and we will have to solve this. So let me show you how to do that. So from here I would move this to the left side. So x negative xi is equal to negative I. I take x out, I get 1 negative I is equal to negative I. So this is equal to negative I divided by 1 negative I. I multiply with 1 positive I divided by 1 positive I. This is going to be negative I times 1 positive I divided by 1 negative I squared, but I squared is equal to negative 1, right? So this is equal to negative 1 of 1 positive I divided by 1 positive 1, which is nothing but this is negative I. So if we were to distribute this, this is going to be negative I squared divided by 2, which is negative I, negative of negative 1 divided by 2, which is negative 1 positive 1 divided by 2. So I can write this as, this is negative I can write this as 1 negative I divided by 2. So that is a value for x. So I got that from here. Now finally you get this. So let me use that. So x is equal to x negative 1 times negative I. This is going to be negative x times I. Positive I is equal to x. So I push this, I get x positive xi is equal to I. So x of 1 positive I is equal to I. So this is x is equal to I divided by 1 positive I multiply with 1 minus I divide by 1 minus I. So this is going to be I times 1 minus I divided by 1 negative I squared, which is nothing but I times 1 negative I divided by 2, which is negative I square divided by 2, which is I positive 1 divided by 2, which is 1 positive I divided by 2. So this is the next root. So I got a root here, I got a root here, and I got a root here. You see that 3 roots I have obtained. So therefore the values for x are 1 over 2, 1 minus I over 2, and 1 positive I over 2. So these are the values. So this is the second way, and we will move on to the third one. Now let me show you the third way, method number 3. Now we have been given this question: x raised to the power of 4 is equal to x negative 1 raised to the power of 4. What I wish to do, I would like to take x is equal to, say, some y positive 1 over 2. I substitute it here, so this is going to be y positive 1 over 2 raised to the power of 4 is equal to y positive 1 over 2 negative 1 raised to the power of 4. This is going to be y negative 1 over 2 raised to the power of 4. Now I want to rewrite this as y positive 1 over 2 raised to the power of 2, and this is raised to the power of 2. Similarly, this is y negative 1 over 2 raised to the power of 2, and this is raised to the power of 2. Now I want to expand this. This is going to give me y squared and positive 2 times y times 1 over 2. That would give me a y here. Positive 1 over 4 raised to the power of 2. This is going to give me y squared negative y positive 1 over 4 raised to the power of 2. Now if I were to expand this, I'm going to use this formula: a positive b positive c raised to the power of 2, a squared positive b squared positive c squared positive 2 times ab 2 times bc positive 2 times ca, right? So if I were to use that formula, this is going to be y raised to the power of 4 positive y squared positive 1 over 4 squared, that's 1 over 16, right? So positive 2 times y squared into y, that's going to be y cubed, positive 2 times y times 4 positive 2 times y squared times 1 over 4 is equal to, I expand this one, expand this side, so it's going to be y power 4. And what I wish to do is, I would, instead of writing it as negative y, I would write it as positive of negative y. So I want to write it like this: y squared positive of negative y positive 1 over 4 raised to the power of 2. So that would be better for me to handle the signs. So this is going to be y squared, this is going to be 1 over 16, this is going to be 2 times y squared times negative y positive 2 times negative y times 1 over 4 and positive 2 times y squared times 4. So this is what I've got. Now clearly you can see that this term y raised to the power of 4 and y raised to the power of 4 can be cancelled. Y squared term will also get cancelled. 1 over 16 will get cancelled. Now 2y squared times negative y, you move it up here, you get 4 times y cubed. 4 times y cubed. You will get 4 times y cubed. And next, is there anything else? And 2y squared over 4, and this will get cancelled. So you have this term left. So 1 over 2y, right? This is 2 divides 4 2 times, so you get y over 2, and similarly 2 divides 4 2 times, you get negative y over 2. You bring this side, you get y over 2 is equal to 0. You add these two together, you get 4y cubed positive y is equal to 0. This is what you get. Now what I wish to do is, I would like to take y out, so this would give me 4 times y squared positive 1 is equal to 0. So from here I would get y is equal to 0. This is one solution, or this is one probability, right? Y is equal to 0. or 4y squared positive 1 is equal to 0, or 4y squared positive 1 is equal to 0. So from here, now let me handle this here. Let me handle 4y squared positive 1 is equal to 0 here. So this is going to be 4y squared positive 1 is equal to 0, which means 4y squared is equal to negative 1, which means y squared is equal to negative 1 over 4, which means y is equal to root of negative 1 over 4, which is nothing but, I want to get rid of this negative, so I place a I squared, so which is going to be I over 2 plus or minus. So this is the value, y is equal to plus or minus I over 2. But we took a different approach, right? We took x to be equal to y positive 1 over 2. Now when y is equal to 0, what happens? So let me just use this part of the space. When y is equal to 0, x is taken to be as y positive 1 over 2. So that means x is equal to 1 over 2. So this is one solution. Now the next is, instead of y being equal to 0, y should take the value of I over 2, right? I over 2. So if I were to take the value of I over 2, say substitute I over 2, positive I over 2. So x is equal to I over 2 positive 1 over 2, which can be written as 1 positive I over 2. This is one root. For negative I over 2, I will get x is equal to 1 negative I over 2. So subsequently I have got 3 roots here. Say this is a root 1, and this is a second root, and this is the third root. So this is the third way. So there are two other methods I want to show you. So let me finish them now also. Students, this is the fourth method. Now I want to rewrite x negative 1 raised to the power of 4 as x negative 1 raised to the power of 2 raised to the power of 2. I expand this, I get x squared negative 2 times x positive 1 raised to the power of 2. I would like to use a positive b positive c raised to the power of 2, which is a squared positive b squared positive c squared positive 2 times ab positive 2 times bc positive 2 times ac. Now the only change I would do is I would rewrite this as x squared positive of negative 2 times x positive 1 raised to the power of 2, so that it's easy for me to handle the signs. So if I want to expand this is going to be x power 4 positive 4 times x squared positive 1, and then followed by 2 times x squared negative 2x positive 2 times negative 2x and 1, followed by positive 2 times x squared. So on the left I got x to the power of 4. So clearly x power 4 gets cancelled. So I get 4 times x squared, and you multiply this, you get negative 4 times x to the power of 3, right? So this is going to be negative 4x, and you have positive 2 times x squared, and you have a positive 1. That's fine. So you can rewrite this as follows. So negative 4 times x cubed, and you can add these two things, positive 6x squared, and then negative 4x positive 1. Of course, what you can do is you can multiply by negative 1 or move everything to the left hand side and equate it to 0. So if you were to do this, you would get 4x cubed negative 6 times x squared positive 4 times x negative 1 is equal to 0. Now what I wish to do is I would like to multiply this entire equation by 2, and I would get 8x cubed negative 12x squared positive 8x negative 2 is equal to 0. Now I want to express everything in terms of 2x. So 8x cubed is rewritten as 2x raised to the power of 3. Fair enough. And 12x, I want to rewrite it as 2x raised to the power of 2. That's 4x with the degree of x being 2. And that has to be multiplied by 3. right? 4 times 3 is 12, or 3 times 4 is 12. And positive, I want to have a 2x here, and then I should have a constant multiple of 4, and I'm not doing anything with the constant. Now what I wish to do is I would like to take 2x is equal to p, so this is going to be p cubed negative 3 times p squared positive 4 times p negative 2 is equal to 0. Now if you were to actually take the coefficients, the terms that you got here, say 1, the coefficient of p cubed is 1, the coefficient of p squared is negative 3, and the coefficient of p is positive 4, and the coefficient of the constant term is minus 2. Now if you add up all these things, so what do you get? 4 added with 1, or 1 added with 4 would give me 5, negative 3 added with negative 2 would give me negative 5. So I add up these two things, I get the value to be as 0. Now if the sum of all these coefficients is equal to 0, then we can clearly say p is equal to, it's arising from the factor theorems, right? P is equal to 1 will be a root, and subsequently p minus 1 is a factor, right? P minus 1 is a factor for this. So p is equal to 1 is a root and p minus 1 is a factor. So if that be the situation, then clearly I can use synthetic division to reduce this. So it's all boils down to synthetic division. So now what I want to do is I'm going to apply synthetic division, take the coefficient of p cubed, which is 1, p squared is negative 3, the coefficient of p is 4, and the constant term is negative 2. So I have p is equal to 1 to be a root. I have found it out, so place it here, bring 1 down like this, bring it down, 1 into 1 is 1, add them up, minus 2 into 1 is minus 2, 4 added with minus 2 will give you positive 2, 2 times 1 will give you positive 2, the remainder is 0. So now what do you have here? This is going to be the term, the reduced to polynomial. So this is going to be, we started with p cubed, so there's going to be p squared negative 2 times p positive 2 is equal to 0, right? So if I were to reduce, solve this by quadratic, let me do that. So it's going to be 2 plus or minus root of 4 negative 4 times 2 divided by 2. This is equal to 2 plus or minus root of 4 negative 8 divided by 2, which is equal to 2 plus or minus root of negative 4 divided by 2. Now I need to get rid of this negative sign, so I'm going to rewrite this as 2 plus or minus root of 4 I squared divided by 2, which is going to be 2 plus or minus 2 times I divided by 2, which is going to be 1 plus or minus I. This is the value of p. Now we already got p is equal to 1 to be as a root, so let me just revert back to the original variable. We started with taking 2x is equal to p, so we have to revert that back. P is equal to 1 is a root, so this means p is equal to 1 is a root, so this means 2x is equal to 1, which means x is equal to 1 over 2 is a root, right? So on the other hand, you get p is equal to 1 positive I is a root, which means 2x is equal to 1 positive I, which means x is equal to 1 positive I divided by 2. So this is one root. On the other end, p is equal to 1 minus I is a root. So 2x is equal to 1 minus I, which means x is equal to 1 minus I divided by 2 is a root. So we got 3 roots. So this is a root, this is a root, this is a root. 3 roots we have got. So this is the fourth method, and I will also show you the fifth method. So students, this is the final method. We are given x power 4 is equal to x negative 1 raised to the power of 4. Now if I were to take the fourth root, I would get x is equal to x minus 1 on one end, and x is equal to negative of x negative 1. Now this is ruled out. This will give us a contradiction, and from here you get x positive x is equal to positive 1, and from here 2x is equal to 1, and from here x is equal to 1 over 2. Now by this technique, the only problem with this technique is you will only get real roots. You will only get real roots. Of course, once you got this real root, you can always use long division to go back and obtain the other roots. So this is the only problem with this technique, whereas the other 4 techniques are sound and solid. So having given you these techniques, thank you students, enjoy your night. Bye bye.